Hey, this is Mr. Ward, and I want to show you a little bit about how you can use the flow chart, this flow chart, to work out what kind of word problem model is the best choice for you. So let's take a look. I made 4 word problems, one for each of the equation forms that we've learned about. Let's just take a look at them. So here we have, for a while, you drove 50 miles per hour north from Dallas, Texas, and then for some other amount of time, you drove south at 65 miles per hour. After that, you stopped to buy some more road trip snacks, and you noticed a sign saying you were 23 miles north of Dallas. So let's consider what this is saying. So there's a 55 miles per hour for some unknown amount of time. That's going north, and there's 65 miles per hour going south. That's the opposite direction, so maybe that should be treated as negative 65 miles per hour. And you did that for a different amount of time. In the end, you stopped and you were 23 miles north of Dallas. It said you started from Dallas. You're leaving Dallas. So now you're 23 miles north of Dallas at the end. So let's take a look at the flow chart and see what it tells us. So is there anything like a rate in the story? Yes, there absolutely is. There's speeds, there's miles per hour. Okay, so we follow yes, and we go here. Are there 2 rates? Well, there's actually are 2. There's 55 miles per hour north and 65 miles per hour south, which is probably a negative. So let's go to standard form. At this point, I'm going to pause the video and let's try standard form here. I'm going to pause the video and challenge you to see if you can come up with a standard form equation for this, just to model this situation. Okay, I have not asked a question. I could ask a question, and I will go ahead and ask a question. If you went north for 3 hours, how long did you drive south? Okay, that's a question that you might be able to answer. So hopefully you have paused. And if you didn't pause, please pause and see if you can come up with the equation that would model this. All right, assuming you have done so, it's a standard form equation. We're going to start off with 55 miles per hour times an unknown amount of time, which I'm going to call x, so 55x. And then I'm going south, which is the opposite direction, so I'm going to make that minus 65 miles per hour times an unknown amount of hours, I should say, called y. So the combination of this, miles per hour times time, that's a distance, and miles per hour times a different time, that's also distance. So because distance equals rate times time. So this right here is going to add up or subtract, in this case, to 23 miles. And that's going to be positive 23 miles. That's 23 miles north of Dallas. Now let's take a look. We actually seem to have a little bit of a problem here because the line is in negative territory here. So maybe it's even impossible for this situation. So let's now see if we can work out, if you went north for 3 hours, how long did you drive south? Okay, let's find out. So north for 3 hours, so that'll be 55 times 3, because x was 3, minus 65y equals 23. Oh, well, actually, maybe that'll work. Okay, so let's see. We've got some information here. So if you went 55 miles per hour for 3 hours, and you went 65 miles per hour south, how long did you do that? Well, in fact, you did that for 2.185 hours. And we can actually solve it algebraically. 55 times 3 is 165 minus 65y equals 23. And then we subtract 165 from both sides. So negative 65y is left on the left equals 23 minus 165, and 23 minus 165 is negative 142. Negative 142. And then, of course, the negatives can be dropped on both sides. We'll be dividing both sides by a negative, but let's go ahead and do that. Y equals negative 142 over negative 65. And you get 2.1 blah, 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 and we'd probably round it to something like 2.2 hours. Okay, so you would have had to have gone 2.2 hours going south at 65 miles per hour for this road trip situation to work. All right, cool. Let's take a look at the next equation. So that one was standard form because you had two rate times time. So speed times time plus speed times time equals a combined distance. Now we've got cookies on the top shelf. They're 45 feet above the ground. You start stacking chicken pot pies on a chair so you have something to stand on to get to the cookies. Now, each pie is 1.5 inches thick, and the seat of the chair is 2 feet off the ground. And then, of course, how many chicken pot pies will you need to get to this 45-foot location? Now, you may notice we've got inches and feet. We are going to need to convert one or the other. So let's go ahead and do that. Let's call that 24 inches. And I'll just leave that as 2 feet just to remind ourselves. This is always a useful thing to work out. And 45 feet, we'll have to work out what 45 times 12 is. Okay, that's 540 inches. So that's 445 feet, 540 inches, which is the same as 45 feet. So now I've got everything in the same unit, and that'll help us a lot. But what equation form are we going to want to use? Okay, what equation form do we want to use for this one? Let's take a look at the flow chart. So is there anything like a rate in the story? Well, you're going to be stacking a whole bunch of chicken pot pies. And so the rate of height is going to change by 1.5 inches for every chicken pot pie. So in fact, yes. Are there two rates? No, there are not. There's one rate. It's 1.5 inches per chicken pot pie. Now, is there a y-intercept? Now, this is an interesting question. So is there a y-intercept? Well, there is a starting place, and y-intercepts are often starting places. So 24 inches off the ground is where you start at 0 chicken pot pies. So in fact, we can treat that as a y-intercept at 0, 24. So let's try. So yeah, if yes, let's try the slope-intercept form. So the slope-intercept form goes like this. Y equals mx plus b. And we've just worked out that the slope, the rate, is 1.5 inches, and I should have had you pause. So go ahead and pause and see if you can come up with the rest of this. So 1.5 inches per chicken pot pie plus B. What is B going to be? Hopefully you paused and you worked out that it's 24. Okay, now see if you can work out how many chicken pot pies, which is X number of chicken pot pies, it'll take to get to these cookies that are 540 inches off the ground. Pause. You should pause and see if you can come up with that. Assuming you paused, we can work that out by saying y equals 1.5, and then we'll plug in. Actually, let me back up. So y is actually the height. So we need 540 inches of height. So plus 24. So we just need to solve for x at this point. So we subtract 24 from both sides. So that becomes 516 equals 1.5x. Actually, right, 516. Okay, 516 equals 1.5x. Because I subtracted 24 from both sides, this 24 goes away. 540 minus 24 is 516. And then we divide both sides by 1.5. So 516 divided by 1.5 equals x. And if you notice here it said that's going to be 344. So you're going to need 344 chicken pot pies in a stack to reach the cookies that are 45 feet off the ground. Hopefully you have good balance. But how the slope-intercept form was your friend. Let's take a look at these two. Mr. Ward owes Mr. Finland $600, but steadily pays him off for 30 weeks. At the end of those weeks, he owes Mr. Finland nothing. How much did he owe Mr. Finland after 9 weeks? So first, we want to come up with an equation. So we know that I start off $600 in debt. So that would be like a negative $600. And after 30 weeks, I have no debt because I've paid him off. So this $600 is a negative $600, like a starting point at negative, so 0, negative 600. You could treat that as a y-intercept. And this 30 weeks is a time when I have 0 debt. So you could treat that as an x-intercept at 30, 0. So let's look at the flow chart and see where that leads us. Is there anything like a rate in the story? Well, you could calculate a rate, but there's not one directly given to you. So let's say no for that. Do you have any sets of related data? Well, actually, yes, you do. You have a couple of points. You have 0, negative 600, and 30, 0. All right, so yes, okay, cool. Are they 2 points? Okay, yes, they are. Are they both intercepts? Okay, so 0, negative 600 is a y-intercept, and 30, 0 is an x-intercept. So yes, they are both intercepts. So try the intercept form. Remember, time is generally x, and outputs are generally y. So let's pause. Please pause and see if you can come up with an equation. Assuming you paused using the intercept form, which is x over the x-intercept plus y over the y-intercept equals 1. Assuming you paused, you worked out that the x-intercept is 30 weeks and the y-intercept is negative $600. Now I'll have to zoom out a bit to see that graph. There it is. It's this green one. I'm going to zoom out a lot to get to where the y-intercept is. Okay, and there's the x-intercept when I get to $0 right there, $30, 30 weeks and $0, and 0 weeks and negative 600. So now how much did I owe Mr. Finland after 9 weeks? So you should pause the video and see if you can work this out, what you'll do to solve that. And assuming you paused, what you're going to do is, since time is x, the weeks is x, we're just going to replace x with 9. So it's going to be 9 over 30 plus y over negative 600 equals 1. And then you're going to solve that. Now, here it's actually given us a y value. I would owe $420 at that point. Ha ha ha, I said 420. I didn't even plan that. Okay, so, but because of middle school, I note that. So 9 over 30, we can simplify 9 over 30, of course. It's probably a good idea. 9 over 30 becomes 3 over 30. Divide both by 3, 3 over 10. Okay, 9 over 30. And now I'm going to subtract that from both sides, and I'll end up with y over negative 600 equals, well, 1 minus 3/10 is 7/10, because that's 10/10 minus 3/10. Now, I just multiply both sides by negative 600, and I end up with y equals negative 600 times 7 all over 10. We can cancel out a 10 from there and there. And now it's just negative 60 times 7, which is negative 420. So after 9 weeks, I would owe Mr. Finland $420. All right, last one. By process of elimination, you can probably figure out where this is going. But 2 days into your journey into the wilderness, you had 120 energy bars. 19 days into your journey, you had 52 left. How many days into your journey will you run out of energy bars if you continue at this rate? So we've got 2 days, we've got 120. So time and a number of energy bars. So we can treat that as the point 2, 120. And we got 19 days and 52 left, so we can treat that as point 1952. Okay, so it looks like we have 2 points. So let's look at the flow chart. So we start off. Is there anything like a rate in the story? Well, there's an implied rate, but we haven't been handed a rate. So we're going to say no right now. Okay, so follow the no. Do you have any related data like XY points? Well, yes, you do. You have 2 points. You have 2, 120 and 1952. So yes. Are they both intercepts? Neither of them are intercepts. So let's go with no. Use them to find the slope. And then if we use them to find the slope, then follow this arrow to try the point slope form. So let's try that point slope form. So the point slope form, I'm going to encourage you to pause this video and see if you can work that out. And then I'm going to work it out myself, assuming you paused. So I know I've got the 2 points, 2, 120 and 1952. And those are my points. And I'm going to need to find the slope for those 2 points. So I'll do 120 minus 52. That's my numerator. And since I started with 120 minus 52, I got to do 2 minus 19. 2 minus 19, that's negative 17. So I'm going to do 68 divided by negative 17, which, oops, let me do it this way. Okay. 68 divided by negative 17 is going to be my slope. My slope is negative 4. So that tells me I'm eating at a rate of 4 energy bars every day. So, and because it's negative, that means they're going away. I'm not actually making new energy bars. They're going in my belly. So they're going away. So now I have a slope. Now the point slope form, of course, goes y minus y1 equals slope times x minus x1. So we can start plugging things in. We know slope is negative 4. And then we just pick one of these points, whichever one we want. I'll pick 2, 120. Let me actually make that minus. So y will be 120 and x will be 2. And now I have an equation that I can work with. Now, the question asked, how many days into your journey will you run out of energy bars if you continue at this rate? Running out of energy bars means you have no energy bars. Now, y was the energy bars, and x is the number of days into your journey. So what we need to figure out is what x would be when y is 0. So you say copy the cost of that equation, replace y with 0, which means we're at just minus 120 equals this. We can divide negative 120 by 4 and not have to worry about distribution here. So let's do that. So I'll factor negative 4 out of both sides. And 120 divided by negative 4 is going to be positive 30. And then I would add 2. I can drop my parentheses now. I can add 2 to both sides to get rid of minus 2. And so 32 equals x. So after 32 weeks, I will run out of energy bars. Hopefully, I can eat something else. All right, I hope that helped. You want to really play around with this flowchart. It will help you if you use it. But my intention of this video was to give you some pointers in how to use the flowchart. You could set up your own flowchart. There are other ways that you could start with. You could start with, do you have any points, and flow through here in a different way. But there you go, and I hope that helps.